Okay, in this video we have to cover something that will come up on the AP, but turns out isn't too important. Well, I won't say it's not too important, but it's a pretty simple concept that is more something you have to understand than something you have to use in a problem. So, Rolle's theorem, to begin with, is one of the important theorems of calculus that has to do with what we just learned with the extreme values. So let's say we have a function. I'm just going to plot something here. If we have a function that does something here, dips back below the axis there, Rolle's theorem says that if you pick 2 points on a function that have the same value, that have the same y value. So let's say right here, I'll change colors there. So let's say right here and right here, that somewhere in between those points, there's going to be a spot where the derivative is 0. So somewhere between these points, a spot is going to have the derivative of 0. So what does that mean? That just means that we look in this section here between them, and we look where the derivative is 0, and the derivative is 0 wherever it's going to change directions. Let's get a line in there. So it's going to be this. That tangent line right there has a slope of 0, so its derivative is 0 there. And it looks like maybe around here too, where I drew it. But we're always going to have at least one between these points. And if you think about it, this actually makes sense, because if we're starting, if we pass this axis, whatever we do up here, we have to end up turning around at some point and ending up back down here if we're going to touch it again. So I think we come up above the axis, and then just whatever happens here, it can be anything, but if we end up touching this axis again, it's going to come back down. And if it comes back down, that means it changes direction at some point, clearly. So we're going to have at least one of those spots. And so in this case, it changed direction right here. And so how this is important is you might get a free response question asking you to explain how you know that you should be looking for a point like this, a critical point like I mentioned in the previous video. If you're looking for an extreme value, you're going to find one between these 2 points. And that's because of Rolle's theorem. And I wouldn't worry too much about it, but it's an important concept to have a handle on. Now the next one is the mean value theorem. For the mean value theorem, this is similar in nature. Let's do a little copy here. If we wanted to talk about the mean value theorem on this same graph, I'm just going to go ahead and get rid of the red here. Okay, I gotta fix this up a little bit for a minute here. Okay, I just wanted you guys to see a similar graph. Actually, let's read this. I'm sorry, this is a little messy. I'll do this. I'll redraw a section on here. There we go. Okay, so now if I draw another curve, I'll make it similar to the last one. Let's blow this up, or if we focus in on a certain area. The mean value theorem says that between 2 points, actually, we'll be better off doing an exaggerated graph here. If we go between 2 points, like this, we pick 2 points on the graph. Let's say this one, I'll go blue maybe. if we pick this point on the graph and this point on the graph, and we draw the tangent, or the secant line between them, sorry, the secant line, like that, there will be a tangent line between those 2 points that has the same slope. So let's see what we have here. It's going to look something like that. And so, say we want to pick another one. Let's do green. If we take this point and this point, let's draw tangent, then we can look along here and find a tangent line where it has the same slope. Looks like right about there. And so all we're saying here is we pick 2 points, look between them, and we'll find one point. For the green, it's here. For the blue, it's right before it, where the derivative there will match the slope of that secant line. And why this is actually important comes up with some corollaries and corollaries to the theorem, but what really matters is that you understand what they're talking about if this comes up on the test. I took the exam in May, and I don't remember ever having to use this beyond simply understanding what they were talking about in the question. And so I think that does both of these theorems justice. In the next video, we'll be going over something that's really important that has to do with the shape of the graph. So thanks for watching, and I'll see you in the next video.